A little bit about us. I'm Wang Tim. I'm currently Apache Hadoop committer at Hortonworks. I spent currently my most of time working on yarn scheduling enhancements. Before I joined Hortonworks, I worked in Pivotal and Alibaba. Yeah, man. Yeah, so Mank is a Hadoop architect at eBay. Currently, he is a Apache Hadoop committer, and also he is a long-time Uzi PMC and committer. He is leading Hadoop core development for yarn and MapReduce at eBay. He was working on scheduler and resource manager before. This is agenda today. First, I will talk about overview and some background of this talk and some problems why we need no labels. And I will talk about what is no label. Follow that, I will give some example to help you understand what is no label and how we can use it. Some architecture introduction, some case study status, and the future of no label. I'm not sure how many of you come to yesterday's my talk. The following few slides used also in yesterday's slides, so I hope you have already forgot. So there's a cluster in a company, and there are a few departments of this company. So we can manage resource by hierarchy of queues. So we can have R and D queue. We can have a sales queue. Under R and D queue, we can split resource to QE team and dev team. We have 5 nodes in the cluster, N1 to N5. Each of the node has 10 gigabytes and 5 cores. So totally we have 50 gigabytes and 25 cores. So when you look at sales queue, it has 50% of the cluster, so it can use 25 gigabytes of memory and 12.5 of cores. Sorry. One queue can have multiple applications. So in the sales queue, we can have multiple applications running. For each application, we can have multiple containers. So one container is a result of resource scheduling, which is a bundle of resource. You can have, say, the container can have maybe 2 gigabytes of memory, 2 cores, and some network bandwidth. And one container will related to some real process. So here we can say for the MapReduce job, there is one process, mapper task running under this container. We have several approaches to manage your workload by queues. So first, we can do it by organization, just like above. You can see the company has a marketing and finance team to use this queue resource. Also, you can manage your workloads, manage your jobs by workload. So you can have a batch job and interactive job. One benefit of doing this is each different kinds of workload will not affect each other too much. And if you have a very big cluster and you have a lot of organization, and under organization you have different kinds of workloads, you can use a hybrid approach. So for example, under the marketing queue, you can have batch queue and interactive queue. So I will talk about the problems why we need no label. Currently, there is no way to specify special resource on nodes. For example, if you have a node with GPU or has SSD, you cannot specify the node has GPU or SSD because in yarn world, nodes is only have a bunch of memory and a bunch of GPUs. A bunch of CPUs. So we cannot say a node has a GPU in the past. And in contrast, there is no way for application to request some nodes with special resource. That is easy to understand because you don't have a way to specify, so you cannot request. And also, you cannot partition a cluster based on authorizations or workloads. So I will come back to them later. So what is node label? Node label is to group nodes with similar profile. So you can group nodes with hardware, with software, with organizations, and also we can group them with workloads. In following, we have different examples to say how you using node label to group nodes with similar profiles. And also, it's a way to make application can specify where to run in a cluster. So if you want to run some nodes with special hardware, you can specify labels when requesting resource from an application. There's some overview of node label. Currently, assume we have a cluster with 5 nodes, 2 nodes with GPU, 2 nodes with NAT memory, and 1 node is some normal node. So we can put GPU partition on the 2 nodes, NAT memory partition on the H3 and H4 nodes. The H5 belongs to default partition by default. So actually, we have 2 kinds of node labels. One is called partition. This is Sense 2.6, which means you can only have one partition per node, and this is related to resource planning. I will come to that later. And also, we can have a load constraint. This one is still work in progress. So when the load constraint can support to specify multiple labels per node. For example, in the H2 node, you can have Windows constraint and also JDK8 constraint. This is not related to resource planning. So here's an example to help you understand what I'm talking about. So, so there's a company. It has 3 different teams: engineering team, marketing team, and sales team. Each of them takes 33% of the cluster resource. So they are very happy to run their job daily in the cluster. So, and someday, engineering team and marketing team wants to have a GPU installed server to do some visualization works. So they spend some money, equal amount of money, to buy some new nodes with GPU. Because they spent equal amount of money, so they want to share the cluster 50-50. But sales team don't spend anything on the new nodes, so it cannot run anything on these new nodes. So here problem comes. If you create a separate YAR cluster, operation team will not happy because operation team needs to manage 2 separate clusters. The operation team needs to manage 2 different set of configuration, 2 resource manager, and because you only pay the same salary, so nobody will happy to do that. So and also, if you add these new nodes to the original cluster, you cannot guarantee only engineering team and the marketing team have preference on this node. Because in YAR, nodes will treat the same. So if sales team has some resource request, wants some memory and GPU and some CPU, it can also allocate to this new node. When that happens, sales team and engineering team and marketing team cannot get resource on that node. So node partition is to solve this problem. We can add a GPU partition in the cluster and put all the new nodes under the GPU partition. You can specify different percentage of shares in different partitions. So for example, here we can see in the right side is a GPU partition. Engineer team and marketing team have 50-50 share of this partition. But in the left side, it's a default partition. The 3 team has 33% of share on the default partition. So we have 2 different kinds of node partition. One is called exclusive partition. Another one is non-exclusive partition. In the exclusive partition world, you can see the the not dotted line. So the engineering team, marketing team, sales team can use default partition, and that has no problem. And only engineering team and marketing team can use GPU partition. Sales team cannot. So even if engineering team and marketing team don't use loads at some time, sales team cannot run any job on this partition. This is very bad for resource utilization. So admin can define the GPU partition is a non-exclusive partition. When the partition is a non-exclusive partition, when it has an idle resource, some other tools can use it. But when the engineering team and marketing team comes back, the sales team will be kicked out. The jobs and the containers will be preempted for the engineering team and marketing team. This feature is available since Hadoop 2.8. Here's an example configuration for the above example. This is for a complex scheduler. So the black text is the original configuration for the default partition. So you can see for different queues, they have 33% of share on the default partition. And also the second thing is the queue echoes. You can see the engineering team accessible node label has GPU. So that means engineering team can use GPU partition. And also you can see the marketing team has GPU partition. You should note that there's for the sales team, it cannot use GPU, so we don't put it here. And there's some, we can specify capacities for node partitions. You can see the engineering team, accessible node label, GPU, the capacity is 50. And also the marketing is also 50. The last one is the optional one, which means we can see what's the default node label for queue. Here you can see the engineering team, default node label is GPU, which means when you submit a job to the engineering team, the job will allocate to GPU partition by default. So this one is just another way to make you understand. So when we without node partition, we have only one hierarchy of node queues capacities. But when we have node partition, we can have multiple. So you can see for the R&D team, in the right, for the default partition and the GPU partition, they have different share of resource. There is some architecture introduction for this. So the central piece is node labels manager. This guy manages what's a node partition or node labels in the cluster. And it also stores labels on a node. It stores a mapping of node to labels. Right. This one can be, when you want to add a node partition or you want to change labels on a node, you have different ways to do that. One is by using command line and REST API. This will directly access resource manager, and the resource manager will call the node labels manager to change labels in the node labels manager. And after that, node labels manager will persist the changes to a file system. So this will be recovered when we're doing RMHA or resource manager restart. And also, you can do this in the load manager side. We can do this in the load manager's configuration. You can say that this load manager has some labels. And also, you can, using a customized script to generate load partitions on the load manager, which means because it is possible, some special things can be easily detected for the load manager. Maybe you want to put the JDK version on the load manager. It's easy to do this by the automatic script. So the first one is called the centralized configuration, because every read and write will go directly to the resource manager. The second approach is called distributed configuration, because we configure everything in the load manager side. And also, once we have configured the labels in the load labels manager, scheduler can use that. So application master will interact with scheduler to send their resource request with node labels. And scheduler will go to node labels manager to see which node has which partition or which labels. So and response to application master allocate resource on these node managers. So the scheduler part is most complex changes for the low level feature, because in the past we only have one dimension of resource. Now we have a multiple dimension of resource. All right, so Mayank will talk about future case study, status, and future of node labels. All right.
Hey, thanks, Wangda. So I'll just go through a little bit here. So based on this feature, what we are trying to do exactly is we are trying to partition the cluster based on different resources, and then applications will come and use those resources and ask for those resources. As of now, there is no way we can do that. But based on this, I mean, I'll talk about the use cases where in different companies and where are we and why we did that. But think about you wanted to use some different kind of resources which, so fundamentally how Hadoop works is you tell resource manager or capacity scheduler is that I want to run this job, and they take a decision based on their resource needs and their resource availability and run the job somewhere in the cluster. But you don't have any say as application to tell that I want to run this particular task or job or number of containers in this particular node. So that is where this feature comes in and gives you that flexibility to do that. And then we have to do actually the work on the whole stack to do that, because you have to do the capacity planning based on that. You have to do the preemption, user limits, anything which are the fundamental features of Yarn. So we need to work on those features to actually get it done based on, because you want let's say if your application wants some different resources, then you wanted to run, and let's say you are an organization where you want to run your jobs onto some set of nodes. But what happens is when your jobs are there, you will run it, but once your jobs are not there, then what you'll do? You don't want to waste your cluster resources, your compute power. So what you do is you will ask other people, other jobs which are running on the cluster can use these resources. However, when you come and you want your resources back, then what you want to do is you will preempt those the running jobs, and you'll give the priority to your jobs. So I'm just giving a idea how this feature will work. So I'll talk about the HP case study here is, so they have one cluster where they have different kind of resource needs. They are different workloads. They have batch, interactive, low latency workloads. So what they are doing is they are using this node label feature to isolate these workloads basically, and then I'll take an example that they are using RDMA nodes to accelerate the shuffle. So they want all the MapReduce job to use those machines. They have high powerful CPUs which are using to run the compression. So they're using those machines. So previously it was not possible in MapReduce or in Yarn. So now what you can do is you can actually ask in your application that I want these nodes where these capabilities are, and then your nodes will, the resource manager and the scheduler will schedule those tasks on those nodes. So basically, they are saying they are able to, in one single cluster, they are able to achieve all these use cases using this. They have all these Hadoop, Vertica, Spark workloads which can using the same, because you don't need to. If you want to use different cluster for different use cases, then probably you need to copy the data. Maybe the data is the same, but you need to copy the whole data into different cluster, which doesn't make sense, right? So they are able to do it because of this feature. So Yahoo also uses node label. We know this tweeting about it, that Flickr is using node labels to partition the cluster and use GPU machine for Flickr images. And they are actually also using partitioning the cluster for machine learning algorithms. So they are running the machine learning jobs, which are actually a very intensive in terms of CPU and memory. So they use this node label feature to do that. I'll talk about the eBay use cases. So we wanted to separate the machine learning workload, because what we are fundamentally seeing is the machine learning workloads are, if you don't have C groups and other features enabled in your cluster, it's actually hampering your cluster resources, other jobs which are running. So what you want to do is you want to separate the high-intensive jobs and which are not SLA critical to a separate partition, and then those jobs will go there, and the rest of the SLA and the production jobs will run fine. So this is one of the use cases which we want to enable. We haven't done that yet because we were looking for the non-exclusive node labels feature, which is coming in 2.8. We want to do that because we don't want to waste the cluster resources. As I said before, if you hard partition the cluster, it's good. You can use that. You can work on those use cases. However, those cluster resources will be wasted when other jobs will come, and those jobs which needs those partition doesn't run right that time. So you don't want to waste the resources. You can use the node label feature for the software. Like, let's say you wanted to run you have some proprietary software which you don't want to. I mean, if you have a big cluster like 4,000 or 5,000 node, you cannot have 5,000 licenses to run the software on those machines, right? So you wanted to separate that piece into some set of machines, let's say 10 machines or 20 machines, where the licensed software can run, and the applications which need that software can go to those machines and run it. So this is one of the use cases which we want to. We want to enable the GPUs. That's the other partition, I mean, like Yahoo. There is another thing, let's say, I mean, if you're running a big clusters and a multi-tenant cluster, then what happens is some groups or some teams will come and tells you that I'm giving you 20 machines, and I want to use them as and when I need it. So you want to separate some of the organizational workload based on that. So you can do it right now based on this feature. I'll talk about a little bit more about how we are using it in Slider. So let's say we wanted to run HBase on your cluster, on a yarn cluster. So what happens is right now is HBase is separate. In most of the places, HBase is a separate cluster. You want to run it somewhere else, and then you have a different yarn cluster or MapReduce cluster or streaming cluster. Then what you do is you need to copy the data from back and forth, right? So what you can do with this feature is you can run HBase on the same yarn cluster, and this is be done by the Slider. You want a better I/O throughput from the region server. So what we did is we have some machines which has SSDs, which we are classifying as a node region servers. And then we have high memory machines or the enterprise machines, which we are classifying as a HBase master. So what you can do is based on, you can have a node label, which we call it as a master node label. And then you can have a node label, which is a region server node label. And all the region server machines will belong, or the SSD machines will belong to the region server node label. And all the master machines will belong to the master node label. So once you start your HBase application as a YARN application, then what happens is a resource manager will put HBase master onto the HBase machine, HBase master machine, and all the region servers will come up on the SSD machines. And you will have your data locality there, right? You will insert, you will update whatever you do in HBase. It will happen, and then what happens is if some machine will go down or some region server will go down, then again resource manager will come and start the region server on the same machine, same set of machines, right? You don't want to toss your data locality, or you don't want to start your region server which is not an SSD machine. So you want to do that in the same SSD machine. So that's the reason this application, the HBase application, will use the node label to spawn the region servers on the SSD machines. Here we are talking about, here some users also submit the MR job, which is MRAM is spawning the task. You can see that the one task is running on the region server machines because there are resources available on that machine. So we are let other applications using that machine and not hampering the region server itself. So I'll talk about a little bit what we have done so far. We have done the exclusive and non-exclusive node partitions in capacity scheduler. which is part of 2.6 is the hard partitioning, non-exclusive is coming in 2.8. We have done the user limit, preemption, everything is now respecting node labels. We have centralized configuration, and we have dynamic configuration is also working on, where you can, every node manager can say that I have these labels, right? So fundamentally what happens is right now what every node manager comes up and tells that this is my resources, this is memory I have, this is my CPU I have. Similarly, it can say that this is the label I have. So there would be two ways. Yeah, admin can go from the CLI or the REST API can say I have these are the nodes which is associated with these node labels. However, the node manager can also broadcast to the resource manager that, okay, I have these node labels. So this is what we have right now in the project. This is a simple UI where you can see that the top level is a partition. So you can say, this is my partition. In this partition, like GPU partition, right? And this is the queue. And then these are the use capacity, configured capacity, actually for this queue under this partition, right? So you can have multiple partitions, and then you have multiple queues inside that, and for each partition and for each queue, what is the configured and the capacity. And then there is a queue status also, which tells that this is my queue which has these labels, right? So this is a simple UI, which is also we are working on. This is the status of other projects which are working, which already supports node label. Spark is already supporting node label. Spark Jira is Spark 6470. MapReduce is already doing that, 6304. Slider already done, as I explained, 81. HBase, Storm, Accumulo, all these can be supported via Slider, and is fundamentally using node labels to do that. There is a very good UI. If you go to the Ambari 10063, you will find out so there is a very good UI for the node labels. I will encourage you guys to do that. Future, so we haven't supported constraints as of now. So what constraints is, like you can say, I want to run my application which has glib version greater than 2.2 and JDK version greater than 7 or 8, whatever, right? So as of now, there is no way you can do that. So constraint is like an attribute or is a condition or as a restriction for your task to run on a particular machine. So what is the difference between the partition and the constraint? The partition is where you can actually have the resources where you can calculate on, so there is no resource calculation or management happens in constraint. So constraint is kind of what is my glib version? You can have a glib version or JDK version, type of CPU, whatever, right? Any constraint you can specify, and then resource manager and capacity scheduler will make sure that whatever the constraints are you specified in your application are fulfilled through when they run their job. In the future, we are working on the phase scheduler patch, which is 2497. And we have to support these node labels into multiple projects like Taze, Uzi, etc. Okay, I'm done. I can take up questions now.
Yeah, thank you.
Thanks, guys.
About the constraints, are they dynamically loaded and checked, or they're basically set on the nodes and or they're statically?
Yeah, as of now, it's admin of the cluster admin does that. It assigns some of the nodes are part of the labels, and then configuration adds. We can add the configuration to the node label manager or the node manager itself, and then resource manager can take the decision. But we can refresh that. If dynamically, if that is what the question is. But yeah, that has to be that has to be driven by the admin using CLI or the REST API.
So, and are there or is there any vision about adding some kind of possibility for running such scripts on the node level through the configuration, so this can be dynamically loaded at runtime of the tasks? Or
yeah, so currently there is one the admin can configure a script in the load manager, which is, can be executed every few minutes, for example. And this can detect what's the property on this node manager. And node manager will contact resource manager about its update. Currently, the Jira is patch is already available and waiting for be reviewed. So I think this could be added to 2.6 or 2.8 as well.
Hi. Okay. Hi. So I love node labels. It's awesome. I was wondering whether it is possible to add preferences. So saying I want red nodes. If those are not available, I prefer blue nodes. If those are not available, I want green ones. And once we have that, can we get rid of locality and just use node labels for that, right? So I prefer to run on this node, if not on this rack, being another label, if not on this pod or whatever.
Yeah, so currently we don't have a mechanism to do that, but I think we can talk about this later to see.
It's a good idea. Yeah. It's a very good idea to fall back onto machines. Yeah, as of now it's not there. We probably need to add it.
Okay.
Actually, I can add to your question. So if you will support or condition on the labels, it would fall in the same category. I want to run on red or blue or green or whatnot. I mean, it will not be really falling back, but it would be either or.
I think that is available, right?
I don't believe that or available. It's actually available, sorry for commenting, Mapar Hadoop distribution, but I don't believe it's available here. So my question is about the difference between node labels and node constraints, because when you're talking constraints, it's literally saying if certain things, then I want to do something. But can't you create a node label, which would be like, this is the constraint, essentially? So you define, you have certain nodes with glibc higher than certain version, and you create just node label on those nodes. And then, I mean, if you can explain the difference between the node label here versus the node constraint.
Yeah, so sorry, I didn't get your.
So I didn't quite understand, like when we were talking about node labels and we're talking about resources like GPU or SSD or whatnot, how it would be different if you defined a node label as a, glibc greater than certain version.
Yeah. So your question is too about what's the difference between node partition and constraint, right?
Yes.
Yeah. So the difference is the node partition is has related to resource planning. So when you define a partition, you should also say for other queues how many percentage of the capacity this queue can access. But when you say it is a constraint, you don't have to do the resource planning. It is a first come, first serve. So which is when you ask for a constraint and you allocate it to some node match the constraint, everybody have to wait for you release resource before they can use. But load partition, if you allocate on a load partition and anybody can use it, if they still under their guaranteed resource, you will be preempted for them.
So think about constraint as a soft restrictions, and the partitioning in the hard labels is the hard partitioning, where we actually calculate the resources and take the decisions based on that, if the resources are available or not. And constraints are the best effort basis. If there is no, if we couldn't find your constraint, we will not run your job. Right?
But then in this case, the follow-up question, if the the node labels or whatever based on the resources is really requires you calculation and whatnot, how those are different from CPU and memory resources?
I think this is a very good question. So, so when you say a node has a partition, you can think the partition has an infinite of resource. You cannot say the node with GPU only have 3 or 10. You can say the node has GPU. It's a node's property, and any request for other resource, for example, memory and CPU, will be allocated on the node with the request partition. But the CPU and memory are finite resource, so you cannot allocate more than the certain number of resource on this node. That's the major difference.
Yeah, but in this case, we are coming again to the constraints, right?
Yeah.
I don't know. Maybe I
Yeah,
don't
so for
understand
constraint,
the
it's the same case. So constraint is also infinite. It's just a property of the node.
Right. Okay, thank you.
Yeah.
I guess I have another question. So how much work has been done and how much work we need to add to prevent user gaming this, right? So why wouldn't I like tag my application with all the labels so they can actually get scheduled everywhere and stuff like that? So how do we defend against user just trying to trick the scheduler by playing with the labels and their requests and so on?
So that is basically you will have a, so you are a user, user will have a quota on the queue, and the queue will have the label. So you cannot run your job outside the queue. You cannot run your job outside your quota. So you can say that I need these labels. However, that will be the admin of the who is actually adding all the labels and giving the ACLs to the queue will determine and then do that.
Okay.
All right. Any other questions? Okay, so no more questions.
I think
Thank you.
yes, I think, yeah.
I just
Sorry.
I just have a quick comment.
Yeah.
It seems to me that the labeling system is more of a authorization system, whereas the constraints is more owned by the application. You know, I have these constraints as to why I'm going to run on a node, whereas the allocations of the labels is something that's going to be handled by the ACLs, and that's more of a
Yeah.
authorization system.
Yeah,
So
so,
that would be the difference.
Yeah.
I would think.
Yeah, I think it is also a very good comment. So node partition related to the echoes and authorizations, admin can specify which tool can access which partition, but constraint you don't have to.
Any other question, guys? Sure.
Hey, so you guys talked about a wide variety of use cases for node labels, all the way from something that's fairly coarse-grained in terms of, doing organizational workload distribution, all the way down to very fine-grained things like glibc. So if you have one cluster, are there good patterns you guys think that should be followed in terms of figuring out how to structure these node labels? Are there internal hierarchies, or how do you manage, say, separating organization 1 versus 2 versus something like glibc? How do you manage all of these on the same cluster?
I think this is a very good question. So actually, this depends on what's your use case. So sometimes you want to partition your nodes by the hardware, for example, GPU, and sometimes you want to partition the cluster by workload. For example, the HP, they are using both ways. They both partition some nodes to run some certain workloads. For example, low latency workload, batch workload, and also they are partitioning the cluster by the hardware as well. Some nodes with RDMA can be run MapReduce job to accelerate a shuffle stage. Yeah. Does this answer your question?
To a certain extent. I guess the other follow-up comment here is, wouldn't having such fine-grained control complicate scheduling significantly?
Yeah, of course, it complicates scheduling, but it gives you some features as well on top of it, because it totally depends upon if you don't want to use constraint, you don't use it. But that is definitely there in terms of how much you give authorization. I mean, in your cluster admin, how it looks into that. If you have a GPU to run, if you want a GPU to run, you don't want to have a spawn a new cluster for just the GPUs, right? So you wanted to, so this feature will give you a flexibility of having those features enabled within the same domain of the operations and can be managed in one cluster. However, of course, there is a complexity added when we are actually trying to box fit the application into multiple constraints and the resources, right? Yeah. So of course, there is a cost to it, but there is no plain vanilla sheet which we have. We can say that these are the best practices you can follow. It totally depends upon different companies to how they look into their workloads. Like HP, they wanted to define streaming and batch differently. So they wanted to have labels for that. In eBay, we don't want that. We just want some like GPU partitioning different, where we looking at just the hardware partitioning, or a kind of workload like machine learning into separate partition. It totally depends upon use case to use case basis.
Okay, all right, thanks.
Yeah.
Thanks. Any more questions, guys? Okay, thank you.
Thank you.